photovoltaic system supplying DC loads. Hello my friends and business partners from around the world. How are you people? Is everything okay with you guys? My name is Rafael. I'm an electrical engineer, and in this video I'd like to speak with you about the photovoltaic system supplying DC loads. And to do so, I chose this exercise. There are some details that we need to understand. I am going to read the exercise so you're gonna get it all. The figure shows an isolated photovoltaic system supplying only loads that operate in direct current, since the system does not have an inverter. The circuit represents a simplified model of the photovoltaic system. In the photovoltaic cell, a voltage drop occurs when the electrons migrate from the semiconductor to the electrical contacts, represented by the series resistance Rs. Completing the panel model, it's possible to observe a parallel resistance Rp, which represent losses due to the reverse leakage current and eddy currents that circulate in all the cells. Questions. Letter A. Calculate the equivalent resistance of the three loads supplied by the system. These are the three loads: 20 lamps, a pump, a radio. Letter B. Calculate the current generated by the photovoltaic panel IPV when all loads are connected. And letter C. Under the same conditions, calculate the current supplied by the battery. The battery is going to supply a current. The values the problem gave us is Rs is 1 ohm, Rp is 210 ohms, Vb is 12 volts, Rb is 20 milliohms, and Is is 9 amperes. With this data, we are going to calculate what the problem wants us to calculate. Let's begin with letter A. Letter A wants us to calculate the equivalent resistance. How are we going to do this? We are going to calculate the equivalent resistance using the powers. How to do this? I'm going to show you. The total power consumed by the loads, total, is equal to, can you see here, 20 lamps. There are 20 lamps. So we are going to multiply 20 times 1.2 watts. Next, we add the power of the pump, plus 96 watts, plus the power of the radio, 24 watts. And then we get the value of P total equal to 144 watts. Okay? We are going to need this result. What we want is the equivalent resistance of this parallel connection here. And how do we get it? See that the real power is equal to V squared divided by R. Okay? What we can do is to pass R to this side and P to this side, and then R is equal to V squared divided by P. Okay? So R is going to be equal to 12 volts squared divided by 144 watts. And this gives 1 ohm. This is the result of letter A. The equivalent resistance of the parallel connection is 1 ohm. Alright. Can we go to letter B? Let's do it. Now we are going to talk about letter B. Letter B wants us to calculate IPV. This is what we are going to do. Calculate IPV. I'm going to erase it here to get some room for our calculation. Okay? Alright. So, IPV is going to be equal to the current that flows here, downwards here, plus the current that goes there, which is IS. Then IPV is equal to IP, okay? I'm calling this current here IP, and the current that goes there IS. Okay, but how do we calculate this? We know that using this, we know this. VP here, and here VB. We're going to need the value of VP to calculate IP, okay? Then here it is RS and here IS. And we get that VP is equal to VS plus VS is this voltage drop here, okay? I'm calling this VS plus VB, okay? VP is therefore equal to RS times IS plus VB, okay? We have this, and we have this. RS is equal to 1 ohm. IS is equal to 9 amperes, and VB, the problem gave us, VB is 12 volts. And then we find the value of 21 volts. Okay? Then IP will be equal to 21 volts divided by this resistance here, RP, which is 210 ohms. 210 ohms. And then this value is 0.1 amperes. And now, using this expression here, we get that IPV is equal to 0.1 amperes plus 9 amperes. And the value is 9.1 amperes. This is the result of letter B. Okay? The current IPV is equal to 9.1 amperes. Are you guys understanding everything? Very good. Let's move on then to letter C. Okay? Letter C is easy. The exercise wants us to calculate the current that the battery supplies. Very easy. If you know circuit theory, you're going to understand it quickly. Okay, just get some room here for our calculation. And now we go to letter C to calculate the value of the current that the battery is supplying, because the battery is supplying power to the system. Okay, letter C, we're going to calculate IB, which is the current of the battery. The battery is supplying the system with a current here. Okay, so IB is going to be equal to I out minus IS. I out minus IS. Where is I out? I out is this current here. I out. I out. Okay? I out is the current that goes to the loads. Okay, so I out is equal to IS plus IB. Okay? IS there plus IB here makes up I out. I out is the sum of this current with this current here. Okay? And then IB is I out minus IS. How do we find I out? I out is going to be equal to the voltage here, VB, divided by the equivalent resistance that we calculated in letter A, which is R equivalent. VB is 12 volts and R equivalent is 1 ohms. Then I out is 12 amperes. Okay? Are you guys understanding everything? Now that we know I out and we know that the exercise gave us the value of IS equal to 9 amperes, then the current that the battery is contributing with the circuit, is supplying the circuit, is IB equal to 12 amperes minus 9 amperes, which is equal to 3 amperes. Okay, guys? Very simple, isn't it? Okay, my friends, this was the video that I wanted to make. I hope you guys liked it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!